Alrighty, hello everyone. So we will get started right now, I guess. So today we are going to start going over some of our programming before we go ahead and enter Pong. So uh, I'll give you guys a second to open up your programs and stuff like that before we get started. Alright, so hopefully you've been able to do that, and now what we're going to do is go over a piece of code that we picked up from online last time, and show you guys how you guys can pick up your code from online as well. So the method that we learned for finding code was searching online for the different code bits, and searching the code bits can be a bit hard when you don't know what to exactly search for. So I'm going to teach you some keywords. So first of all, you're going to want to make sure that you have Python typed in, because when you go ahead and you search up certain things, you could get many different genres, I guess, or different languages regarding different solutions to the problem that you asked and the problem that's at hand. So instead, what's going to happen is just type in Python first, make sure the computer doesn't get confused, and once you make sure that the computer knows exactly what you are referring to, then you can go ahead and ask your question. So next thing would be trying to be as specific as you can with your question. So in this case, it would be looking for Python Pong game, right? But we can't just go ahead and search for Python Pong game, because it could give us the pseudocode, or it could give us like a actual working version that is just run on a website or something like that. So instead, what's going to happen is we need to plug in code at the very end. And again, if we don't want Pygame in there, we can always type in without Pygame, but it doesn't really matter, as we do have the Pygame package installed from last time using tic-tac-toe, so we will just continue to use it, and I guess we can go work around the problems if we have any. So last week we went through some of these, and this one was the one that we copied over into our IDE. Next time, this class, we are going to go ahead. We're going to go into GitHub. So GitHub is generally pretty good for finding your pieces of code. So we can see there are a lot of comments on here to kind of guide us, to tell us, is this a program that works consistently? Is this a program that accomplishes what it needs to be, done? And is it something that's like too convoluted, or is it a concise solution? So we can just go ahead, take a second, look through these comments, but what happens is you need to kind of learn how to analyze these yourself. So I'll give you guys a second, and then I will go ahead and go over them myself. Alright, so hopefully you guys were able to kind of scan through some of these. So what's happening here is, essentially, in this first one, it's a good piece of code, and all the lines having this to this, as Python 3 does not give back integer with normal division. So that's obviously the one major complaint that this person had. So we can go ahead and look at the code. So this kind of code over here, it can always be updated. That's the good part about GitHub. So it looks like this person did not go ahead and do that. So when we go ahead and we write this code, we will need to do this ourselves, and if we run into that error, obviously. So we do have the most recent Python version, so we will most likely run into it. So what we can go ahead and do is we can just copy and paste this into our IDE. So in this case, it is going to be PyCharm. So I'll go ahead and switch that to this window, and we can see, all right, there's a lot of code here. It doesn't look like there's any errors. We only see like green underlines, which is just formatting errors and naming errors, that kind of stuff. So it's nothing really big or anything like that. So we detect that there are no problems, so we are good to move on. So what we can do is we can just go ahead, click on run, and we can see run Pong test. And when we run it, we can see, alright, well, we got to the position in which, or we got to the situation where we could actually see the paddle. So if we know how to control it, we can see, alright, so what happens is we receive an error every single time the ball reaches someplace. So at this point in time, we can look back and we can determine, okay, what's happening is float object can't be interpreted as an integer. So this goes all the way back to that comment that we found talking about how we want the slash to be a double slash. Well, what in the world does this mean? Well, if we go back to Google, and Google is really helpful. Essentially, the problem with using a single slash is just regular division. So if I were to plug in, say, 13 over 5, you would see that we get 2.6. But in Python, if we were to do 13 over 5 using a double slash, what happens is it only returns the integer part of the answer, or 2. It will always round down. So what we can do is we can Google what is the difference between slash and double slash in Python, right? Remember, we used the keywords in Python here, and we made sure we stated our question clearly. So we can see there is a fairly good question here that relates to what we were asking as well. And we can see, all right, so proves almost all the time that A over B is equal to A over B with 2 slashes. And we can see, all right, there's clearly something up, right? Well, what we noticed is that in this comment over here, it mentions Python 3, right? And if we go back to over here, we can see that the tag is Python 2.7. So looking at versions is very, very important. We have the most up-to-date Python version installed if you installed the Python package with us. So Python most recent version, and we can see that the most recent version is 3.9.1. So we are in version 3, we are not in version 2.7. So what happens is it will answer, somebody will most likely try to answer, and we will see if it's an answer that we are going to be happy with, right? We notice that immediately it splits it up into Python 2 and Python 3. We can completely ignore Python 2 since we're not using it, so we can jump directly into Python 3. So in Python 3, dividing two integers results in a float, but using double slash acts as an integer division. So we can see 10 over 3 is equal to 3.3 repeated, and 10 over 3 is equal to 3. So with this new knowledge, we can now go back to our Python code and understand why we actually need to change this piece of code so that it can work for us. So we need to go through the entire program, and we can change every single one of these slashes into double slashes. Obviously, we can use Control F to find the location of every single slash, so it is much, much easier for us to locate it. And after doing this, we can now go ahead and I guess be comfortable with the fact that we know exactly what is happening. So it seems like we caught all the slashes, and obviously it will give us an error if we don't. So we can run the program again, and we can check, alright, the ball now does run, and the game is running perfectly fine, right? So say someone scores, and we can see that the score becomes 0 to 1. So this is a working package over here. So this is something that it's something that you can literally just go ahead, download into your computer. follow the same thought process as we did over here, but obviously you can do different things as well. Like you can go ahead and change certain parts of this function in order to make the game more fun, right? But that's also going to be part of what's going to be happening in this class, and we will send out an email with the working code for Python 3, so not the code directly from GitHub, which is designed for Python 2 and not 3, right? So now that we've kind of gotten the basis that this program indeed does work, so we can see it does use Pygame, so obviously we will need, oh, I just realized that entire time you guys couldn't see that. We will have to rerun this game. So there, you guys should be able to see it now. So if I were to run Pong test, and you can now see the game working in its in the way that the game should work online, as we saw last week when we searched up Pong game, right? So if we were to let someone win, we can see that the score does increment on both sides, and it will start in the middle, go in a random direction, or at least semi-random. So now that we've determined this, we can now go ahead and start trying to analyze this code in a way that we can actually go ahead and really understand what's happening, obviously. So when we look at this code, we can immediately tell it's a pretty long piece of code. It goes down to 200 lines. And if we were to analyze the different sections that this code is split into, we will notice there's a very, very similar, I guess, structure to that of how we did the tic-tac-toe, where we have all of the instance variables, or the global variables here rather, defined at the very top, and then we have our methods at the bottom, right? And finally we have the game loop over here at the very, very bottom. So one thing we'll notice is that, once again, just like the example in last week, the idea of classes and objects is not used again, right? So obviously in this kind of case where there are two different players, it is possible to use classes and objects, although it's not necessarily necessary to use classes and objects. So in this class we will teach you how to transform these kinds of bulkier codes into a format that can use classes and objects. So what do I mean by this? Well, immediately I can go ahead and point out a couple of things that could be simplified upon using classes and objects. This entire bulk of code over here, where you have to copy and paste every single one of these, you have to change all of these from paddle 1 to 2. You can notice these are all paddle 2 and these are all paddle 1 over here. And every single time you write a piece of code to mimic the way paddle 1 behaves, you have to rewrite the code for the way paddle 2 will behave in the exact same way by copy and pasting, instead of being able to just call the instance of the object, right? This is one of the more basic ways we can simplify this code, as it's the classic example of two variables. So I will go ahead and do a brief overview of what is happening here. So the way the methods are structured are quite similar to the way a class is structured. So you'll notice that they do in fact have an init method. In general, what this init method means right here is it's kind of just a place to define variables. In the case of our class and object example code, we can notice that what's happening is the init is used to define all the class variables. In this case, there is no class, although they do use the concept of init. Init, in this case, is just defining every single global variable over here. And you'll notice that for the variables that were defined up over here, they use the word global in order to indicate that it can be accessed everywhere within this block of code. The second part is there is another init function. This is called ball init. Ball init is essentially the defining function for variables just for the ball. So these are event handlers and this is the ball. What do these mean? Like, what in the world is an event handler? Well, an event handler is essentially when the ball makes contact with a racket, when the ball is moving across the board or your screen, whatever you want to call it, how do we make it move and what controls it? those are the two main things that are going to be happening here, right? And in addition to that, how are you going to make the paddle move, right? So these are all event handlers, how we can make these objects move. Next thing is we have our draw function, right? So it says we draw a function of the canvas. What does this mean? Well, we can notice that immediately when we run Pong test, we can see that it has this initial screen over here, and we can see this board. And this board is what this draw function is doing, is creating rather. It's drawing all these lines, putting the backgrounds, placing the scoreboard, placing the original position of the paddles. Not the position of the ball, that will come in later, but that is the states of things after the draw function is written. So draw function is extremely important in making that initial state for everything to work off of, right? So in this case, this draw function is rather bulky. So what do I mean by bulky? Well, there's a lot of code in here. It takes up like almost half of the entire block of code. So we can see it goes from 64 all the way to 140, and that's almost 80 lines. So it's not really ideal to have a function this long, as the entire point of a function is to be able to kind of make the code concise and easy to follow. Obviously this is not easy to follow. This can easily be cut in half. As we can see, there are a lot of copies of each one of the paddles in order to define each one as the same thing. This can be easily cut down if we go ahead and we make our classes in the upcoming classes. But first we want to make sure we can even get the Pong game to work and we can understand what is going on. Going through our draw function over here, we can notice it draws some lines, it puts the paddle position, and then it will also set the paddle color, and it will set the paddle position after it gets this information and stores it into the correct variables here. Next thing is it has to determine when the balls collide, how it will look on the board, and the changes in the X and Y values, because in the end our entire canvas is just a huge coordinate plane, right, that we need to be able to learn how to navigate precisely. So this portion over here deals with the ball collisions and with the paddles. So these are top and bottom walls, and these are as well as gutters, so meaning what happens if someone scores, right? Well, when someone scores, obviously the score has to change, so we can notice this is where the score changes. And this code is once again copied and pasted. Next thing is we can see, alright, this is the final update score, which is obviously copied for both of the different paddles. Very unfortunate. Our next method is going to be the key down. What does key down mean? Well, if we take it quite literally, it means key down when you press a key. In this case, the way you are going to actually navigate using these handles is actively going ahead and pressing the W and D keys. The W and D keys, or W and S keys, my bad, as well as the up and down keys for both of the paddles. So you'll notice I can't really show myself pressing the keys, but when I press S, this left side goes down. When I press W, the left side goes up. Down makes the right side go down, and up makes the right side go up. So that is key down. It needs to make sure that it properly controls, it has the proper controls. Later on, if we are to make this a more complicated program, or rather an easier to play program, we can make our own keys such that if the user wants to make them like spacebar and escape, they can put spacebar and escape with no problem. That will be using the idea of input and output, which is really fun to use, especially when you like to cause havoc. And obviously it's just something fun to go ahead and play around after we get to that stage, obviously. So obviously, once you go ahead and you calculate the key down, you also have to calculate key up. Key up is going to kind of calculate, alright, once this key is pressed and once I let go, what has to happen? Well, when you set key down, what happens is it actually sets a variable. It sets the variable velocity. That's what VEL means, velocity. What does velocity mean? Well, velocity is actually a little bit of an inaccurate term for this. A better term would just be speed, because velocity has both speed and direction. By just putting speed, it would obviously be more accurate, because the speed would allow us to know how fast it's going. So it will set the speed, and once it sets the speed, it will go ahead and go at that rate. So essentially, every single time the frame updates and we have our key down, that will be the rate. Now, if we are to not change this again, if we press it down once, then it will constantly stay at this, right? So essentially, it's like sticky keys. I actually don't know how sticky keys work, but that's my assumed definition. What I mean by that is essentially, once you press it, it will continue to be pressed until another key is pressed. Obviously inefficient. There's not really a reason as to why you would want to do that. So instead, when it is key up, it will just set the value as 0, so we know that the paddle is not moving again. The final portion of the code is going to be our actual game loop. So the game loop is quite simple. It just needs to make sure that it calculates, or calls rather, the first method, which is drawing and defining the different functions here. So you'll notice that it will just go ahead and call draw over here, and draw will go ahead and call init, and init will define itself. It will define all the variables that it needs, and everything will work out just fine. This is a interesting approach to creating the Pong game. What do I mean by interesting? Well, it's essentially just one big method. That is not entirely the most efficient way of going about it, as if you were to go ahead and make a mistake, it would be a real mess to go ahead and try to correct it. So we will go ahead and be able to split this kind of code up into multiple bits, where we can go ahead and make it a much more understandable and flowable block of code. The draw function is not really a draw function, it's more like a main function, so that's obviously not how it's supposed to work. Another thing we can do is, once we split it up into methods and we understand where each piece of code is located, we can start making changes and edits to the code with much more flow and ease, as the methods actually mean what they mean, right? So I will give you guys a second. Take in what I said. I said a lot of stuff, going over like the entire piece of code here, but obviously I want to make sure you guys really understand what's going on. So I will give you guys a second to kind of catch a break and before I move on, essentially. Alright, hopefully that was enough time to kind of catch what I was saying. So the plan moving forward is going to be, so the first step is splitting this into individual functions. So in this class, I will be able to go ahead and tell you how are the places where we can go ahead and split it easily, and then in the next class we will actually go ahead and write that code in a new version. So this piece of code right here, everything here, will be emailed to you guys as soon as I can get it to you guys, so should be pretty soon. And I guess now we can go ahead and show the places where we can split the code. So up until this part over here, pretty much it's all just drawing. So that means that it is actually an accurate representation of how the draw function would work. So what can we do? We can just go ahead and end this function over here. So we can just type end right here, right? And this is where the next function begins. This next function deals with all the collisions, right? It's pretty self-explanatory, and we can immediately tell it ends right here, right? Why can we tell it ends right there? Well, we can see from the comments from the user who made this code that they put this calculates the collision with the top and bottom walls, and this is the collision with the gutters or the paddles. So we can end this function right over here. And finally, we have our update scores, and it will obviously end where the function ends. It's a fairly short method, right? And just to kind of make sure we really know what's going on, so if we were to go ahead and run this code, we can tell exactly what each method is doing. So from this point, we can see if the ball is to collide with the floor. We would still need a good example of that. There we go. It will just go in like a direction that kind of makes sense, right? Now let's mess with it. Why not just go ahead and play around a little bit? So we can see this is ball collision with the top and bottom walls. So what we're going to do is instead of just changing the ball velocity by 1, we can go ahead and change the ball velocity by, say, 5. So this is pretty drastic, so I expect a pretty big change. So if we were to go ahead and run it, and it will collide with the top wall. Oh, it crashes. Because, oh, we messed with the wrong thing. That would be why. So what would happen actually instead is, say, we actually have to write it out here in order for it to work. So we'll make it 3 times this time. So if it is to collide with the top wall, so we can see it drastically changes its direction. Obviously, this direction doesn't make sense, and it goes like that when it collides with the ceiling too much. So playing around with these numbers can be really helpful in learning the code and what this means. We can obviously add a little bit of random multiplier if we are to import the random package, and just stick that in some places. Obviously, we won't make it too much of a random multiplier, otherwise it would be too hard to play, but just a little bit of randomness can make this game a lot more fun, obviously. Make sure if you're going to go ahead try and play around with the code, you do save an original copy. That is something that is very important. If you find a copy of the game that you create that you really like, then you can go ahead and save another copy of that game, right? It's perfectly fine for you to go ahead and do that. It's obviously just a way for you to track your progress, because from then on, you might go ahead and accidentally destroy what you created, and then you won't have any progress of it, and you have to restart, try and backtrack your thoughts, and it's all going to be a mess. So just save it. Makes life a lot easier. So that's kind of how we can go ahead and play around with these numbers here. So next thing is we can go ahead and play around with this key down here. So we are going to put an inputs function into here, in which we can put whatever keys we want in order to control either paddle. And once again, any keys. It could be TG, it could be O and L, it could be the enter and shift key, right? Any keys. And this will all be controlled by the user when the game begins. It will be an option for us. And once we go ahead and we finish that up, it's a little bit of input. We can go ahead and convert this into classes and objects. That will be our final step, as it is a pretty hard step in converting a piece of code that's not quite class and objects into class and objects. And finally, you guys will be able to tinker around with the game, create your own version yourself. So that is the general outline, the general plan of what is going to be happening over the next couple of weeks. So I see ZPU asked, can you change the code to have different colored paddles? Of course you can. If we are to go ahead and come over here, so we go and see our draw function, we see that it draws the lines over here. When it creates the paddle, it has to set the color, so we're gonna have to find that. So I can see that it has some colors over here, so if I were to go ahead and run the code and look at the initial color of the paddle, it's green, so we can just Control F green here. And we can see it draws this polygon over here with green. So we want to make the paddle red over here. What we can do is we can make this red by changing it to red. Why can we change it to red? Well, we have the variable defined up here. You can't actually just go ahead and type in red unless you have it defined. These are known as the color codes. They can be converted into hex codes, which is the more common, I guess, more everyday use of the way of tracking colors, but this is the way that programs track colors. So, and in case you guys want to know, this one controls red, this one controls green, and this one controls blue. RGB, it's the way the computers are able to control the colors for each one of the pixels on the screen. So now that we've changed it, we can go ahead, run this again, and we can see that this paddle is now red. Hopefully that answered your question, ZP. So now we can go back. If you have any other questions, feel free to ask them. But for now, that kind of wraps up the class for today. And I guess I'll see you guys next week if you don't have any questions, and we can follow through with our plan. Yes, CP, the code will be sent after this class. So when you get it, then you can go ahead, copy it onto your own computer, and then you can change the code however you want. Alright, it looks like no one has any questions, so thank you for watching, and I will see you guys next week. Thank you.